Okay, welcome. We're going to be doing a review of Integrated Math 1 to get ready for the benchmark. This will be the final review, and then you can show me what you know and how you've paid attention and learned. So, one problem on there that we've gone over some, but I want to go over it just a little more, is if you have one like this, and we discussed this some yesterday, or yes, so here we go. In this problem, we know that we're going to use the arithmetic sequence. So I went ahead and gave you that, like you'll get it on the test. So now we're going to substitute the numbers into the equation. Now let me point out something. These are the n's. That means like the nth term. First, second, third, fourth. So the nth, it's like the nth term. That's what the n is. So that's why it would be like there. And then a would be your terms in the sequence. 6, 12, 18, 24. Okay, so we're going to do the arithmetic sequence. So we're going to do a sub n equals a sub 1 is the first term. So your first term is going to be 6. Then you put a plus. And the difference is, what's the difference between your terms? And as we go along, we're doing what? Good. We're adding 6 each time. So we have a difference of 6. And then you just put in minus 1. Okay, so we've gone over that. Now the thing is, we want to also then look at what our different, what the answer choices are. Okay, now this first one, this is actually the geometric is where you have an exponent. So that is when you are multiplying. So that answer cannot be correct. This one, let's compare this with what I wrote up here. What's the difference between this and that? Good, it's the plus sign in front of the 6. So that is going to work. So now we're down to these two. So to decide which one is going to work, you're going to want to simplify this equation. So here is what I mean. You're going to want to take this part of your equation, and so we have 6 plus 6 and minus 1, and we're going to want to solve it. Solve it just like it's an equation. Just like it's an equation. Sorry about that. And so we're going to do, don't call me after midnight. So you're going to do the distributive. So 6 times n is 6n, and 6 times a negative 1 is a negative 6. Okay, it's don't call. That was distributive. This is to combine like terms. So I can divide these two because they are like terms because they don't have any variables with them. 6 minus 6 is 0. They cancel out. So you're left with 6n. So it would be this a sub n equals 6n, which is the same thing as that one. All right, let's look at the next one. We're going to look at problem 8 from your paper here that I had, because we haven't gone over this one. So I want to make sure you understand this. So let's look at number 8. You can get that into focus. Okay, here we go. Actually move it down a little bit. Sorry, this is not perfect. We just kind of got it together last minute, so it's not totally working great, and I'm going the wrong way. Okay, here we go. Let's look at number 8. Okay, it says, so Catherine Catherine places 8 eggs into an empty top hat. Each egg weighs roughly the same. The weight in ounces of the top hat and eggs can be calculated using the expression 4x plus 5. What does the term 5 represent in this equation? Okay, so let's go back through the steps that we learned from Coach Harris. So Coach Harris told us that you want to use the common sense, you want to see if you can eliminate, and you want to draw, put your pencil to paper. So I'm going to think about this as kind of an image that I start off, look, you start off with an empty top hat and you're going to place eggs in it. So I'm actually on here, I'm going to think about kind of like this is a top hat. All right. And it weighs some amount. I don't know how much. And then I'm going to put eggs in the top hat. A top hat. Don't know how many as of yet. Okay. And then it says each egg weighs roughly the same. So these weigh the same. The weight in ounces of the top hat and the eggs. So we're going to do both. Can be calculated using the expression 4x plus 5. What does 5 represent? Well, it looks like to me 5 is what you started with. And we started with the top hat. So that means this weighs 5 ounces. Well, if you look, guys, that's all you had to answer in this problem. We don't have to do anything else. What does the 5 represent in this equation? So which answer would it be? A, the weight of each egg. B, the weight of the empty top hat. C, the number of eggs in the top hat. Or D, the total weight of the top hat and eggs. Good. I would agree. This is B, the weight of the empty top hat. That's before you add anything to it. And it's probably going to be 4 ounces per egg. All right, great. Let's go to the next part. For the next part, when we saw what was on the test, one thing that we saw was that when they had domain and range, they had them look like this in the final answers. We have not. We have not been using these signs, which means infinity. Let me tell you all that is, so don't panic, okay? We just had this as the answer. So you're basically going to take the infinity sign off and the inequality sign with it. So it's like that goes away. And so that's the answer we have looked at. Okay, so let's look over here. Okay, I'm going to take away the infinity sign and the inequality sign that goes with it. So that's going to leave that part. Now we've done all of ours with the with the variable first. So I'm going to take this and I'm going to flip it all over. So I'm going to move the y to the front, the 4 to the back, and then I need to reverse this sign because it needs to always point at the 4 and open to the y. This is what our answer would look like on the graph. Okay, so I want you to try this. So let's say we have one that the answer looks like, oh my goodness gracious, I am making a -8. It looks like that. Okay, what would you think of this answer? If this answer is on the test, how would you possibly rewrite that on your paper as how we did it? And this would be for the domain, because remember, domain is X and the range is Y. Very good. You're going to take all of that off and you're just going to leave that part. Okay, now let's look at this example for the range. Okay, I'm going to start off with, let's say, 2 less than or equal to Y, less than or equal to infinity. What are you going to do here? Good. You're going to take this off, the infinity sign and the inequality with it, which leaves you with this. Just like we did here, we want to reverse it. So we're going to put the 2 in the back, the Y in the front. If it opens to the Y, this one needs to open to the Y. So this would be the final answer there. All right. We've got a couple more examples. Okay, so we're going to look at number 10. Sorry, it's a little blurry as I'm trying to get here. Okay, let's look at number 10. Okay, so we did this one with Coach Harris. Okay, so for this one, let me move this down a little bit here. Okay, it's saying what value of x does f of x equals 2? Okay, first thing I want to remind you, f of x, it is the same as the y. Okay, those are the same thing, f of x. So basically, what is x if your y is equal to 2? So here is y. You might have just heard my dog bark. Okay, so I'm going to make a line across on the 2. That's not a very good line, Mrs. Jones. Let me try that again. Okay, so where it crosses over that line, where the y is a 2, for the x, it's at the -1. It's at the +1. And it's right here at the 7. Well, let me look and see which one of those answers is here. Would that be a -1, 1, or 7? Well, it's 1, so I'll go there. Well, let's say that it asked me this same thing, except for it wanted to know if f of x is equal to 4. What could be some of my possible x answers if f of x is equal to 4? What could some of my y values be on this line? Okay, good. It could be here, which is at the -2. That could be an answer. Slide it up a little bit. Or it could be here at the 4. Those could be your x values. All right, let's look at number 12. Oops, no, sorry, yes, 12. I just lost it and took it away, and I didn't want to do that. Okay, on number 12. Okay, I got to go back up a little bit so we can see it a little better. Hopefully it'll stay for me now that I went down with it. Okay, so here we go. It says, and this one I think is a little bit harder. I'm going to cover up the problems above it just so it can stand out a little bit. Okay. It says the value in thousands of dollars. Okay, so we're talking about thousands of dollars. So if you have a 1, it's going to mean 1,000. If they put a 3, it's going to mean 3,000. Okay, the value in thousands of dollars, V, of a savings account is given by the function V and then in parentheses T, where T is the number of years since 1993. So I'm already thinking some important information here is that V is the value in thousands and T is the number of years since 1993. Well, let's look at what it's asking. Which equation indicates that the investment has a value of $4,800 in 2003? Okay, now remember T would be the years since 1993. And we're currently in this problem in 2003. So let's see how many years have passed, how much time. So to find that out, I'm going to subtract these. That's how I find out, oh, you can't even see it. That's how I find out the difference in years. Okay, will you please subtract that and see what you get? Good, that will give you T. So T is going to be the time, because the time. So in V, with a T in parentheses, this 10 should be in parentheses. Look, I've already found the answer. But you can always look, whatever that is, it's going to be equal to $4,800. And remember, we're writing this in thousands. So these two would be the same amount if this was written in thousands. $4,800. Okay, very good. Let's go on. The next one we're going to look at, we have two more, is we're going to look at this one. Whoa. Okay, guys, you're going to be asked to solve equations or inequalities. So remember, when you do that, it's don't call me after midnight. All right, what step then are you going to do first? Good, you're going to do the distributive first. So you're going to do, that's going to be a negative 2n minus 12 equals, and then you just bring this down. Okay, so next is C, which is combine like terms. We don't have any like terms over here or any like terms over here, because if one has an N and one doesn't, they're not like terms. Okay, what does this M then stand for? Good, we're going to move the variables to the same side. So I'm going to actually move this one. The inverse of a negative is to add. So I'm going to add 7n. A negative 2 plus 7 is 5n. Minus 12 equals 8. Now I'm at A, which is the inverse of adding or subtracting. So I'm going to add 12 to both sides. And this is a one-step equation. So my last step is to divide by 5. And then I end up getting n is equal to 4. You will have a couple problems like this. If this was an inequality sign instead of an equal, you're still going to follow these. Don't call me after midnight. Distributive, combine like terms, move variables to the same side, inverse of adding or subtraction, inverse of multiplication or division. The only thing that is going to be different here is if you divide or you multiply both sides by a negative, you would reverse the inequality sign. So if this had been a negative 5 and this was an inequality like this instead of an equal, we would have to reverse it to that when we divided by a negative. Okay, last problem. We're going to look at problem number 23. This is one that you have not seen at all. And so we're going to look at it. Just got to find where did I put it here in my stuff. And so here we maybe possibly go. Sorry guys, y'all get to sit there and wait for me to find it. And that's fine. Okay, I found it. All right. So, here it is. Now this seems like a lot, but we're going to make it where you're going to be like, oh, that's not bad at all. Okay, sorry, my chair is a little squeaky here. Okay, it says given the function f of x is equal to x plus 2. Okay, that's one of our functions. And g of x from the table. So it's kind of like this equation, this function is in this table. Select all statements that are true. Okay. I personally want to make my f of x and my g of x in the same form. I don't want one to be an equation and one to be a table if I'm going to have to compare if they're equal, their slopes, and all of this stuff. So what I'm going to do on my scratch paper is I am going to make them both a table. Okay, this table we already have. I just copied that down from the paper. I then made a table here and I put, for the x values, I took these x values and I put the same ones here. So now I'm going to substitute the x in for x and solve to get the f of x. Here's what I mean. I'm going to do a negative 6 plus 2. And negative 6 plus 2 is a negative 4. So that goes here. Now I'm going to substitute in a negative 3. A negative 3 plus 2 is a negative 1. Will you please now figure out the last two on your own? Good. You substitute in 0, 0 plus 2 is 2. Substitute in 3, 3 plus 2 is 5. All right, here are what the statements are on your answers. The first one is that f of x is equal to g of x. That you have the same thing both times. Well, no, obviously not. They're different. Okay. And the next one says the slope of f is less than the slope of g. Slope is the rate of change. So here each time we're going up by 3. And here each time we're going up by 3. So this one, obviously, it has a slope of 1. This one over here, it's going up by 3. In the x, and in the y, how much is it going up by each time in the y? Good, it's going up by 6. So, and remember, slope is a change in y over x. So it's going to be 6 over 3, which means this one has a slope of 2. So the statement that says the slope of f is less than 2, that's a correct answer. Okay, here's another answer. X has a value of 1 when f of x is 3. So that's saying that this x has a value of 1, and that would make this 3. Well, yes, if this x is 1, 1 plus 2 is 3. So that one's true. Okay, and the next statement. I'm gonna put these here now. So we've said they were not the same. So we eliminated that one. We said yes, a slope of f was only 1 and the slope of g was 2. So that's an answer. We said yes, that's true, because if you made that x a 1, 1 plus 2 is indeed f of x is 3. So let's look here. The y-intercept of f is less than the y-intercept of g. Okay, let's look back at what we drew. The y-intercept is always when the x is 0. What do you notice about these two y-intercepts? They're the same, they're equal. So one is not less than the other. Last one that we're going to do. X has a value of a negative 3 when g of x is equal to a negative 4. Well, let's see if that's true. When x is a negative 3, g of x was a negative 4. So that's true. So when it says all, then it would be B, C, and E. All right, good luck on your test.